Okay, in this problem we looked at earlier, we had this sheet of paper and we folded the corner over to touch the bottom and form this little triangle down here. And we calculated the area of this particular triangle, which you can see is actually the area is 6 units squared. But we calculated it by making a formula for the area that was based on how much of the paper was kind of peeled off and folded over. And just as a reminder of how that formula worked, the top part, the part that's being peeled down, we called that x. EC, this length down here, which is the height of the triangle, that's 9 minus x, because the whole paper is 9 spaces tall, and this is just what's left over when you peel off x, so 9 take away x. EF, right here, which is the hypotenuse of our right triangle. It's just x because it's the same amount of paper that's peeled down. And then to find FC, we had to calculate a squared plus b. We had to use a squared plus b squared equals c squared. Of course, we already knew the hypotenuse, we're trying to figure out for b. So we went a squared plus b squared equals c squared. We took a squared from each side, so b squared equals c squared minus a squared, and we took the square root of both sides to get this. B is the square root of c squared minus a squared. And c squared minus a squared, well, c we already determined, that's EF, and that was just x, so it becomes x squared. And a squared, well, a is just EC, which we already determined was 9 minus x, so that's minus 9 minus x squared. And then the area of the triangle was just base times height divided by 2, and the base and the height are FC and EC, so we just put those into the formula, and so base is square root of x squared minus 9 minus x squared. The height is just 9 minus x, and it's divided by 2. And then we plugged in x equals 5 into our formula to see if we got the right area, and we did. So the next question is, what value of x is going to give us the largest possible triangle? And as we talked about before, in this particular case, x has to be a number between 4.5 and 9. Because if I fold the paper down, and here's 4.5 right here, if I were to fold the paper down at 4.5, the only way for it to reach the bottom of the page is to fold straight down D, straight down to C. You'd be folding the whole paper exactly in half. If you fold it any higher up than that, then the corner can't reach the bottom at all. And anyways, in that case, the area of the triangle would be 0 because it wouldn't be a triangle. The largest x could be is if we were to fold the whole 9 inches all the way down, and just kind of give you a picture of what that would look like. Right? That'd be like folding the paper over, all the way over flat like that, in which case, again, no triangle at all, and the area would be 0 of the triangle. So what we're going to do is we're just going to pick some numbers in between 4.5 and 9 and kind of get a feel for what's going on in this situation. So what I've done is I have this recreated, and I'll pick this up just a little bit so you can see the whole table all at once. There we go. Refocus here. And we're going to pick lengths of 5, 6, 7, 8, and 9. Alright. Now let's just do our calculations. And we've got our different formulas here. And the area formula, we don't actually have to plug all that stuff in because we'll already have the numbers over here. So if DE is 5, then the height of the triangle, 9 minus x, must be 4. EF is 5. And here we would have the square root of 5 squared minus 4 squared, 25 minus 16, which is 9. The square root of that is 3. And so the area is 4. Right? We want to focus on EC and FC. 4 times 3 divided by 2, which is 12. And that's the one we already did, actually. If we fold the paper down 6 units from the top, that leaves us with 3 remaining units. So I just realized that I'd done that last calculation completely wrong. I should have had the diagram in front of me. I was just more careful about it, which is why I edited that out of the video. I don't normally edit the videos. It takes too much time. So let's do it over again. All right, if I cut the triangle, if I cut the paper at 6, then for EC there are 3 remaining units. EF is 6, just like before. So we do our square root of, it's square root of 6 minus square root of 3, which is, oh, not 3, just regular 3 squared. 6 squared is 36. 9, which is square root of 27. And now its area is the height of the triangle. That's EC, which is 3 square root of 27 over 2. And that number, 3 times second square root of 27, and then divided by 2, is 7.79, so we'll just leave it at 7.79. Approximately equal to 7.79. So it looks like it's a little bit smaller than the original. So let's go ahead and, other than the first one we did, we'll just make some more space here. Let's do 7. Okay. So let's see. If we cut it off at 7, then the triangle is 9 minus 7 is 2. And then here, and that's 7. And then to calculate our base of our triangle, it's 7 squared minus 2 squared, and that's 49 minus 4, so that's 45. Square root of 45. So it'd be square root of 45 times 2 divided by 2. And that's just going to be square root of 45. So second square root of 45. 6.7, we'll round off 6.71. Okay. Then we had, next was 8. So if it's 8, then the remaining portion is 1. That folded over portion is another 8. To calculate the base of our triangle, we've got, let's see, 8 squared minus 1 squared, that's 64, minus 1, that's 63. And it's going to be square root of 63 times 1 divided by 2. Or square root of 63 over 2. Get our calculator out to see what that is. Second square root of 63. And divide that by 2. We get 3.96. We'll make it 3.97. Alright, so it looks like overall our largest area is in fact when the triangle is at, let's see, 5. All right. Except that I just recognized that I made a second mistake here. No big deal. Area equals 12. That's not right. It should be 12 divided by 2. I forgot to divide by 2 in the end. So that's 6. So our largest area happens when I make the cut at 6. So let's go see if that's actually true. And here's how we're going to check to see if it's actually true. Okay. I'm going to go over here to this graphing utility. There's our formula. And this is what a graph of all the possible areas looks like. So you can see here, between 4, that's 4.5 right there. And if I were to fold the paper over at 4.5, I get no triangle, so no area. And there's 9. That's the largest possible. If I fold it over at 9, then I also get no triangle, no area. And right here, if I fold it at 5, I get that area of 6. So over here, 6, all right, and 5. So if I fold the paper over at 5, then I get an area of 6. And then we saw that the max area appeared to be when we folded it over at 6. So it'll be right here. And if you look, actually, really close, but the machine seems to think that there's a number that's just a little bit larger, or a little bit less, I'm sorry. So the fold is 5.99999, like 569, some like crazy number like that. So what looks like what's happening here is that this is just sort of a difficult to work with function, and it's not going to have a nice maximum value at a whole number. And there are methods we could use, but they're way beyond the scope of this class. So what I'm going to have you do instead is, for your similar problem to this, let's go back here. All I really need you to do is, find the area of your triangle, write your formula, which is going to be pretty similar to the formula I came up with. Find out what your constraints are, so what's the smallest and largest x could possibly be, and then just hit every whole number in between there and kind of see if you can narrow it down to some sort of a range. It has to be kind of in between these two numbers, or in this area. Finding the actual maximum triangle area is going to be outside our ability. Okay? And there you go. Good luck with that.